Hello, in this video we will be explaining the forest fire prediction project. Let's introduce the dataset. This is the forest fire dataset sourced from UCI machine learning repository. It contains real-world data on forest fires. The dataset is designed for regression tasks with the goal of predicting the burned area of forest fires. The data is categorized into four main types: discrete data, continuous data, categorical data, and ordinal data. Let's start by importing libraries. First, we will import pandas, which is used for handling the dataset and performing data manipulations. NumPy, which will help with numerical calculation in array-based operations. Train test split from sklearn model selection. It splits the data into training and testing sets. MLP Regressor from sklearn neural network allows us to build and train a neural network regressor. Let's start with data pre-processing. First, let's load the dataset using pd.read_csv, which reads the CSV file into a data frame. Let's explore the dataset by using the head function. Let's simplify the dataset. We remove categorical variables like month and day. These columns are not suitable for regressions as they cannot be directly compared or processed mathematically. This leaves us with clean dataset, DS, which is ready for further analysis. Now, splitting data into training and testing sets. We will divide the dataset into training and testing subsets using train test split function. Here how we allocate the data. 70% is used for training the model to learn patterns. 30% is reserved for testing to evaluate the model. Let's store the features, which is also called independent variables, into xtrain and xtest. Now let's store the target variable area into ytest. This preparation ensures that the model is trained and tested on different data, preventing overfitting. Now let's build and train the neural network. For this, we use MLP Regressor from scikit-learn. To build our neural network regressor, here is how we configure it. The random states equal to 1 ensure the model produce consistent result each time we run it. The max iteration 500 limits the training process to 500 iterations, ensuring the network has enough time to converge. Now, using the fit method, we train the model on the training data, xtrain and ytrain. During training, the neural network learns the complex relationship between the features and the target variable. Now let's make prediction and save the prediction results. Once trained, the model is ready to make prediction. We use the predict function to predict the burned area for the test dataset, xtest. These predictions are stored into a data frame and we will export it to a CSV. Let's name the CSV, which can be analyzed further. The final step will be evaluating model performance. For the limitation of this video, we will be using MSE, MAP, and R2 score. Mean square error, or MSE, measures the average square difference between the predicted and actual values. A lower MSE indicates better performance. MAP, on the other hand, expresses the prediction error as a percentage, making it easier to interpret the model accuracy. R2 score will evaluate how well the model explains the variance in the target variable. An R2 score close to 1 indicates that the model performs exceptionally well. To conclude, in this project we learn how to process data, build a neural network regressor, and evaluate performance using real-world data. By combining these steps, we are able to predict the burn area of forest fire effectively. In the next video, we will learn how to improve the model predictions results.